All right, so number 1 here in section 8.2, it says where necessary, round your answers to the nearest hundredth. So in question number 1, it says verify that 5, 7, that's a point, 5, 7, that's 5 units over to the right from the origin, and then 7 units up. So verify that this point is a solution to the following system of equations. So with these two lines, one line and one parabola, they're saying, let's figure out and prove that this is a solution. So this is at least one intersection point between this line and this quadratic here. Okay? So to verify, all we need to do is we need to plug in the values into each equation and test to make sure that the equation is true. So K and P, I guess the only issue is which is K and which is P. That's a good question. Doesn't really give us much information about that, does it? Usually in alphabetical order is going to be the x-axis is going to be like the first one, and then, so let's try that, K and P. I don't know, doesn't really tell us, but. So, and it probably won't work in either direction, right? That doesn't count. So it has to be the right way, like P and K. So let's try K is 5 plus P is 7 equals 12. That checks out. And over here, if we had K is 5, it would be 4 times 5 squared minus 2 times P would be 7 equals 86. So this is 4 times 25 is 100. Minus 14 is 86, and that appears to be true. So it appears that 5, 7 is a solution to the system of equations, just by plugging those numbers in. Okay, any questions about that? Any problems with that? Any clarification needed? All right. So 2 is not part of your assignment. 2 is very similar. It's just dealing with fractions. Okay, I can come back to that if you want, but 2 is, you do it the same way. Number 3, here's where we may start running into some problems. Maybe, yeah. Let me just do a couple here from 3. If you're having trouble with E, maybe we can do E. So solve each system of equations by substitution and verify. So we are using substitution. I'll do A, that's the first one. So substitution works when you can isolate one of the variables and substitute what it equals into the second equation. So it doesn't matter which one, what you solve for. You wouldn't want to solve for x here in the first one because you don't want to take the square root. That's a mess. So solve for y, either in this one or this one would be good. So let's see. Let's do. Let's work on the first one. So I'm going to get y all by itself. Actually, I'm going to add y to both sides. So it's going to be x squared plus 2 equals y. Does everyone see that? So now I've got y isolated in the first equation. So wherever I see y here, I can now substitute what y equals. So it's going to be 4x equals 14 minus this expression right here. Use your brackets so you don't, so you don't mess it up, because this negative sign is going to have to be distributed like that. Usually the x squared term, let's get that to be positive, so let's bring that over to the other side. It's going to be positive x squared over here, plus 4x. 14 minus 2 is 12. That's a positive 12 over here, so it's going to be a negative 12 on the other side. I did a couple steps at once there. Hopefully that doesn't mess you up too much, but anybody have any questions about what I just did here? Okay, good to go there. So in order to solve a quadratic, you have some options: factor, zero product principle, or quadratic formula, or you could graph and find the intercepts. Really 3 different things you could do. So if we try and factor this, let's see if we have some fractions or integers as solutions. Is there anything we can do here? Yeah, it looks like, yeah, negative 2 and 6, positive 6, that works. That multiplies the negative 12 and adds up to positive 4. So x, possible solution would be positive 2 and negative 6. Well, that's for the x values. For the y values, we're going to now figure out which y value goes with x equals 2. So we can go ahead and plug x equals 2 into one of these equations. And this is going to be 4 plus 2 is 6. So it looks like 2 goes with 6. And for negative 6, that's going to be negative 6 squared is positive 36 plus 2. So it looks like it's going to be y equals 38. All right. So solve each system. So it appears that these are 2 points, 2, 6, and negative 6, 38. To verify, you can plug each of those points into the equations and see if they're true. Or if you want to graph these, you can. You can use Desmos as well. Or you can use your graphing calculator and graph and check the points. But anyways, I will leave that to you to check. Okay, and I'll maybe show you the graph here and we can check that on Desmos. Okay, so here it's graphed on Desmos, and if I go ahead and click here, look at that, negative 638 is one of my solutions over there, as well as 2, 6 is my other one, so this is confirmed. Okay, so that's for A. Perfect. Whoa, that's big. Let's make that smaller. Okay. Okay, so I did have a question about E as well. You said, are you still struggling with E, or? Yeah, yeah, a couple of you? Because the answer is yeah. Oh, no. The answer is no solution. Yeah. Ooh, fun. Fun. Okay, so what does that look like if there's no solution, which apparently is the case here? Let's explore a little bit. Let's do substitution. So this first equation is y equals x squared minus 2x minus 6. And so let's substitute this into the second equation for y. So the second equation is going to look like this, x plus, and then what's y? Well, this is y. And minus 3 equals 2x squared. Okay, so I've just plugged this in right here in for y. So if I gather like terms and get everything over to the same side, what do I have? Well, let's take everything over to the right side. I'm going to subtract x squared, so I'm going to have just 1x squared over here. I'm going to have, let's see, I'm going to subtract an x and add 2x, so this x, that's going to be plus x over here when I combine these and then move them over. This is substitution? Yeah, so the substitution part came when I rearranged this first one. I got y all by itself, and then I plugged what y equals from the first equation into here, the second equation, and that's what I got here. So now I'm just combining like terms and moving everything around a little bit. I think I've done that correctly. Just double check here. So I have negative x over here, it's a positive x squared minus x squared over here, and then negative 9 becomes a positive 9. Okay. So can we factor this? Let's just see what happens. So I have x and x. What two numbers multiply to 9 and give me a difference of x? Okay, 3 and 3. Problem here, though, is that if they're both positive or both negative, that does not add up to 1. So that's a problem. So what you could do then, you could use your quadratic formula, right? X equals negative b, that's negative 1, plus or minus the square root of b squared minus 4 times a times c. And right away, I see a bit of a problem. The problem is this discriminant. Now, did I call it a discriminant with you guys? Yeah. So b squared minus 4ac is like the really important part here. This will tell you whether you have one solution, two solutions, or no solutions. So it's underneath the radical sign, the root sign. So if this turns out to be negative, then we have no answer because you cannot algebraically take the square root of a negative number. So what is this? This is 1 minus, what is that, 36? Ooh, that's negative 35. That is a problem. So that would indicate to us that there are no solutions. So when you see this, you have to take the square root of a negative number, red flags go up, and you say, guess what? That means there's no solutions, which is not a big deal. That just means that if we were to graph each of these two relations here, each of these two, then there would be no intersection points. They would just be, we have a parabola, we have two parabolas, and looks like they wouldn't touch at all. They would just be, so let's just confirm that. So let's graph them out. So as we graph these two in letter E, you can see that they just kind of nest in each other. There's no intersection points at all. Okay. So that's E. Any other questions about E here? Yep. All right, so 4A is asking us to solve using the elimination method. So here's method number 2, elimination. So what you want to do is you want to rearrange the terms in these equations so that the like terms are lined up in vertical columns with each other, and the equation, the equal sign, is also lined up. So I have x squared right over top of each other. That's great. I have x terms right over top of each other. Awesome. Y and constants. So this is arranged properly. Now what you want to do is you want to probably multiply either one or both of these equations so that you can eliminate the y term. Okay, you're never going to eliminate both, well, not never, but most likely you're not going to eliminate both x terms. So you want to eliminate the y term so there's only one variable left to solve for. So what can I multiply one of these by in order to add them up so that they cancel each other out? I heard you over here, what'd you say? Yeah, bottom one by -2 is perfect. Because what will that do? Well, that will give us -4x squared minus 2x equals -2y plus 8. And that's important because now we see that the 2y plus -2y, those are going to cancel each other out or eliminate. That's the name of the method. So we eliminate the y. So 6x squared minus 4x squared is going to be 2x squared. And -3x plus -2x is -5x equals, the y's are gone. That's awesome. -5 plus 8 is +3 over here. So now we have a quadratic. Let's get everything over to the same side. Let it equal 0. And then we can go ahead and solve for this x using quadratic formula or factoring or whatever. So let's see. I always like to try and just do it factoring. You know, I don't know if we can try it. Will it work? 3 and 1? Oh, it should be. 2 times 3 is 6, and 1x is, that should get us to 5. So if it's a -6x and a positive 1x, that'll get us to 5. And this will multiply to -3. So our x values appear to be -1 over 2. If you let this equal 0, solve for x. And x equals also +3. Okay. Just stop me if I'm going too fast here for this. Are you guys okay with it? So use the quadratic equation, you got different numbers?
No, I did it with the quadratic equation. I got
Okay, Mr. Babel, double check your signs there.
Yeah.
Make sure A is 2, B is -5, and C is -3 for quadratic. Let me know if you still have trouble. I'll continue on here though. If x is what do you mean? Yeah. So the question was, are we adding or subtracting the equations? Well, if you get this to be the same number but opposite sign, then you add. So that means you add all the terms. If they're the same number and the same signs, you can subtract one from the other. That's fine. I always like adding though. I always like, because it's you make fewer mistakes if you add than if you subtract with the negatives and stuff. Can be tricky. Okay, so if x is -1/2, let's find out what y is going to be then. So you can pick either one of these. I'm going to go with maybe this one here. Like 2 times -1/2 squared plus -1/2. And then +4 would equal y there. See, for this one? So what's that? 2 times 1/4, that's 1/2, minus 1/2, plus 4 equals y. Well, that's 0, so it looks like y equals 4. Yes, no? Okay, you guys can double check that. I'll do the next one here. X equals 3. Okay, so let's plug it. I'm going to plug it into the other equation now. So 6 times 3 squared minus 3 times 3 equals 2y minus 5. That's 6 times 9. What's that? 54 minus 9. And then I'm going to go plus 5 equals 2y, so I'm going to divide everything by 2 to get y over here. So what's that? It's 59 minus 9 is 50. Divided by 2 is 25. Equals y. If I've done that correctly. So it appears that my solutions are -1/2, 4, and 325. So if I've done my algebra right, those are the answers. And then you can graph that or whatever to double check those. So graph those on Desmos, and yeah, the intersection points here are -0.5 and 4 and 325, so they do check out there. Okay, so that's 4A. So just to once again, for those of you that maybe missed that, in C, for example, you have P and M. So P squared and P, that's kind of like the X squared and X, and then the M is like the Y. So you would probably rearrange this so you can eliminate the M term. Yeah, and for letter C here, you're probably going to want to rearrange, things so that you have. So I'll rewrite the top one.
Did you do it to isolate M by itself already?
Well, you're going to want to eliminate M.
Yeah.
Yeah.
So can you do it so M is on the one side of the equation?
Yeah, you could rearrange it so that M is on the one side if you want. Yeah, it doesn't matter. I'm just going to go with what the top. You just have to line them up. Doesn't matter. So I'm going to get the P squareds over here. So that's going to be a -5P squared. And then equals, yeah, so I'm going to 10P. That's going to be a regular 10P. And then the -5M is going to go over here. And then the 8 is going to be a -8 over here. Yeah, so in order to eliminate the M here, you're going to want to multiply the top one by, maybe 5, and the other one by -2. So they have to be opposite signs and multiples of each other. So I'll just do one more step and I'll let you guys take it from there. Plus. So it looks like in this one, when you add them together, you're going to get rid of your P term and your M term here. So go ahead and finish that up. C if you haven't done C yet. Give you a few minutes to finish that one up. So just a note here, grade 11s, that in this case, when we added the equations together, there was actually 2 terms that got eliminated coincidentally. You don't need to do that, but sometimes that'll happen. In this case, both the M term and the P terms got eliminated, which makes a little bit of an easier equation for us to solve. So you divide both sides by 20, and your P is plus or minus root 2.3 or plus or minus 1.52. And then you go ahead and you find your M values for each of those, and you get your points. So here's the worked out solution here from the solution manual. So you can take a look at that. And then of course you would check either graphically or by plugging all these numbers in and making sure they work in the original equations. So I'll give you a chance to look at that.